So I'm gonna start step by step, and I will try to explain some problems and some the context and some related material as I discussed the solution. Of course, I won't give you the complete solutions, but you have to tell me that if you are okay with proceeding on your own, and then I will stop. So let me start with problem number 1. So in problem number 1, complete the Gram-Schmidt process in problem 8, computing Q1 is equal to A divided by the norm of A, and then A2, and then Q2, and so on. This problem is actually very simple, but still I would work this out, this problem partially. So Q1 is equal to the vector divided by the magnitude of vector. So your vector is 1, 1. So now the magnitude of that vector, vector A, is 1, 1. Magnitude of A is equal to square root of 2. So you're gonna have 1 divided by square root of 2, 1, 1. Your Q1 is going to be 1 divided by square root 2, 1 divided by square root 2. Second step is now you have to find A2. This A2 is the next vector B, and then we have to find out the projection of B, which is B transpose, to find the dot product Q1 multiplied by Q1, and this vector is 4, 0 minus 4, 0, 1 divided by square root 2, 1 divided by square root 2, then multiplied by 1 divided by square root 2, 1 divided by square root 2. And can someone tell me what is the answer that you got? 2 minus 2, right? Then you have to find, are you with me? Any questions? Everyone got that answer? Okay. So next, I can't see. So next is finding out Q2 is, are there any questions here? Okay. So Q2 is equal to A2 divided by norm of A2, and that gets 1. B minus B transpose Q times Q, right? Oh, yeah. Okay. So okay, in the question it said A transpose Q1, right? That is not Gram-Schmidt. It should be B transpose, because we already found out the orthogonal vector for A. Now we have to take that and transform B. So the next, can you see that? Okay, I need to write this down. Actually, so B is equal to 4, 0. So we already have A. Now we have to transform B. So this is going to be 1 square root of 2 minus 1 square root of 2. And then, so next thing, what you can do is, if you want to do the QR decomposition, you can say your vector is 1, 1, 4, 0 is equal to Q1, Q2 multiplied by norm of A 0 to square root 2 norm of A2 square root 2 or you can use MATLAB at this point to verify the answer that I have. So you can actually check this answer. MATLAB. Okay. Everyone good with first problem? Very good. How many of you did not do the first problem? Everyone did first problem? Very good. So I'm sure you must have done second problem also, right? Now come on. The second problem is fill in the blanks. Oh yeah, somebody already gave the answer. I was not going to solve this one. Yeah, that answer is correct. Okay, if A is equal to QR, A transpose A is equal to R transpose R. That is nothing but lower triangular times upper triangular. Gram-Schmidt on A corresponds to elimination of A transpose A. Everyone understood problem 2? So is fill in the blanks. So the answer is lower and upper. Problem number 3. Okay, how many of you got problem number 3? Okay, there are multiple ways of solving this problem. So let me ask you, how did you solve the problem? Go ahead.
I just used MATLAB and I set A equal to ones parentheses size of t, and then I did the defit, which is related to A times A transpose times A divided all divided by A transpose times B.
Okay. How about you? Do you solve the problem?
Pretty similar, yes. It's actually just a step by step, like as it is written in the question. It's pretty.
Okay.
It's x is equal to inverse of the square matrix that we get by transpose it, and
Okay.
solve the point. Give me like.
Okay. So, how about anyone else? Got the problem? Not got? Didn't get the problem. That's okay. It's okay. So I will solve this problem. So this problem is actually super simple. And to be honest with you, there are multiple ways you can solve this problem. Okay. So what I'm gonna think about it, we have data points. So the data points are, you have values of B and values of A. Values of B and values of A. And these are the points. These are the points. So what do we want to find out? We want to find out the line that goes through this, right? We want to find out the line that goes through this. How do we define line? Line is nothing but y is equal to mx plus c. Do you agree with me? Y is the value of B and X is the value of A. So basically these Y's are 0, 8, 8, 20 is equal to, what you have is, you have M. M is multiplied by X, which is 0, 1, 3, 4 plus C. Now, how do we solve this problem? And I want you to observe this problem written something like this. I'm gonna, for the sake of simplicity, I'm gonna rewrite this problem as 1, 1, 1, 1 multiplied by C. Do you agree with me? So now this equation can be written as in the form of linear algebra. The linear algebra is AX is equal to B. So this equation can be written as 0, 1, 3, 4, 1, 1, 1, 1, MC is equal to 0, 8, 8, 10. Are you with me? Now solving this problem should be simple, right? You got A, this is your A. So you would do A transpose A, X is equal to A transpose B, and then to find X, you would do A transpose A inverse A transpose B. Are you with me so far? Then you will get the equation of line. Now, how do you find out the error? To find error, what you need to do is you need to find out the projections. So to find out the error, you have to find out the projection. So to find error, I'll try to show you. Say if your point is over here, and you can find out this projection. E1, the point is here. You can find out the projection E2, and then you will do E1 square plus E2 square, etc., etc., and that will give you the answer. So what is the value of E you got? What is total E? Everyone got 44? Okay. Everyone got right? Oh, definition of vertical. Okay, then that is actually it is super simple. If you want to do vertical,
I think choose vertical, but then in the left figure it gives the projection on. We have to take the projection on the vertical.
you do both. You both basically you should get the same answer. Basically, you would see that the values will be different, but you can find error as a projection or you can find error as a vertical. That will be fine. So you if you did y expected, y obtained, that basically you did the vertical. Okay, so next problem. So problem number 4. Anyone got the answer? Did anyone solve this problem? Okay, how did you solve the problem? Any questions, ideas, suggestions? Yeah, go ahead.
I just did it based on. I said so that I said so the equation a plus delta a squared minus a squared all over delta t is just simplified down. So I just did plugged in its values and set up that equation and simplified it. So I got 2a plus delta a dA dt.
2a plus
Delta A.
delta a dA dt.
It's like a simplified. You're looking at it's like the change. So you're using the factor. So it's Pythagorean theorem. No, it's final squared minus initial squared.
Final minus initial square. So a t dA by dt plus dA by dt at. This is what you got? Yeah.
Maybe in the book, like one formula is given for that, like just like as they have written here, that you must compute a plus delta a of squared and subtract a squared.
Yeah.
So the equation number 12 in the book is indicating the indicating that. So
Okay. So how did you do it with equation 12?
I guess from equation 11, I just replace inverse with squares. So b square minus a square is equal to b square into a minus b into a square, and then place the values of equation 12 in that.
Okay. And what is the answer you got?
I got that like negative a plus delta a whole square into delta a upon delta t into a square. So like as equation.
So okay. Okay, so let me write that equation. So are you talking about this equation? No, right?
Yes.
Is this the equation you're talking about?
Yes, yes.
Okay, what did you do next?
Replace a inverse with a square.
A inverse with a square.
Yeah, but actually like first I the value in equation number 11, so the equation before that, and then like put the values in these equations.
Okay, just bear with me
So
for a
we will get this.
okay, probably
Basically 11 and 12 equation are connected. So by placing the values of A, we find the equation number 12. In both the
okay, yeah. So that's totally fine. Let me just make sure that I have just bear with me for a second. Let me look at my notes here. Yeah.
I will say 280 dA by dt plus d square a by dt square.
Okay. Let's look at all these answers. Page 163. Okay. Okay, 163. Okay, page 163. Which equation did you use? 11. 11 is B inverse A inverse is equal to B inverse yeah, derivative of A inverse. That is the same equation I wrote. So Hello? Okay, now they can hear me. Okay, blame Zoom for it. Okay, all. Okay, can you hear me? Okay. There's some issue with Zoom, but we will continue. So this is 0. Okay. So you should be able to see my screen. So in the next problem, problem number 5, what you need to do is, this is the equation that is given to us, and then we have to verify the derivative. So dA by dt inverse. So dA inverse by dt is 0 minus 2t 0 0. Then you have A inverse dA by dt multiplied by A inverse. So you need to show that this is minus 1 t square 0 1 multiplied by 0 minus 2t 0 0, and A inverse, which is 1 minus t square 0 1. So I want you to just verify for derivative for A inverse, and you should be able to get dA by dt. So this is dA by dt. So this 1, so 0 2t 0 0. This is A inverse minus dA by dt. This is A inverse. So you should be able to verify the answer. So next problem. Yeah. Yeah, you can actually put this matrix. So you are given these two matrices, right? Yeah, you just use these two matrices to verify. So use these for verification. Everyone understood? Okay. All right. The next problem Next problem is easy. Did you get this problem? So find the eigenvalues for A for lambda 1 t and lambda 2 t, where they have given the equation for A, equation for A, and then so what values of lambda 1 and lambda 2 you got? Yeah, but finally you simplify what you get.
One, yeah, 1 plus t plus or minus a square.
Correct. 1 plus t.
Plus or minus. So that's both lambda 1 and lambda 2. 2 plus 2t plus t squared. Oh, no, it's 2. Inside the square root, it's 2 plus 2t plus t squared.
Is this what you got? Okay. Then what at time t is equal to 0? What you got? You got the values of lambda 1 and lambda 2. Okay. Then how did you get the eigenvectors? Did anyone use MATLAB or no? Okay, good. What did you get from MATLAB?
Okay. Right. So this is kind of long. So t plus parenthesis square root of t squared plus.
No, you need to find those values at
zero.
t is equal to 0. You can substitute t is equal to 0 and then get the values. No worries. So you will get, so that's what I wanted to tell you. That long expression, substitute t is equal to 0 and you will get a small expression. So that is what is.
Here we go.
Yeah, tell me.
So for the eigenvectors,
Mhm.
it's square root of 2 plus 1, 1 minus square root of 2, 1, 1.
Okay. So you substituted that in MATLAB, right? So,
Yeah.
okay, that's fine.
That was the matrix and one from row from the.
Okay, that's fine. So next question number 7. Were you able to get question number 7? Yes. Okay, good. So I'm going to work out this problem, but anyone else who got question number 7? Okay, so the problem is simple. So you have 3 nodes, 1, 2, 3. One, 2, 3. So you are going from 1 to 2. Yes, Gazi, you can talk to me after class. But please note your messages are seen by everyone. So 1 to 2, then you have 1 to 3, and then you have 2 to 3. So the way I'm gonna write this expression is I'm gonna write down in form of equation starting from 1 going to 2. And so the weight here is C1, weight here is C2, weight here is C3. So this equation is going to look like this: minus C1 x1 plus C1 x2 is equal to 0. Because you are going from 1 to 2. So x1 minus x2. Now, if you look at the second node, you are going from 2 to 3. So this is gonna look like C2 X2 plus C2 X3. And the last, you're gonna start from 1 minus C3 X1 plus C3 X3. Are you with me so far? So this is the network. And now what I need to do is, in this network, I'm going to write this something like minus C1, C1 minus C2, C2 minus C3, C3. Are you with me so far? Yeah. Yeah.
So usually, when the graphs and all this stuff,
Uh-huh.
so we have this matrix from where we travel, right? So if I'm traveling from 1 to 2, we keep the weight as C1. If I'm traveling from 2 to 1, it's minus C1.
So 1 to 2 is C1.
And it's from 2 to 1, it is minus C1.
Oh, just bear with me for a second. Just bear with me for a second. It can be done multiple ways. Just bear with me for a second. So this can be written as and then what you can do is you can actually compute the incidence matrix A trans. So this is your A. So you can actually compute A transpose C A, and you will get, and I would encourage you to do this in MATLAB real quick. So put this matrix and verify my answer. You will get minus C1 minus C2 minus C1 C1 plus C3 minus C3 minus C2 C3 C2 plus C3. Yeah.
We not get the X1 and X2. What?
Okay. So X1, X2, and X3. So this problem can be thought of in terms of the graph theory problem. This problem can be looked at as electrical network problem. This problem can be looked at the traveling salesman type of problem. So there are different ways of looking that problem. So what I'm going to say here is node 1, at node 1, you assume there is a variable x1. If you are going from point 1 to point 2, that means you are going from x1 to x2. So your equation that describes this travel is this. It is because I want to write that as a spring multiplied by displacement is equal to external force type of problem. So don't worry about the right hand side for the time being. So you can ignore the right hand side for the time being. But finally, what you would have is you will have the equation written as the matrix, and then this is your matrix A. Before I go further, let me ask you this. Did you try if you use this matrix A? You did, yeah, A transpose C A.
Yeah, but the answer that I'm getting is like pretty similar, but C1 and C2 and C3 are
C2 C2 and C3 are switched. Okay, so when I look, I'll try to solve this. Let me see. Oh, yeah. I made a mistake here. So basically, this, oh, this is 2, this is C3. C2, what answer I got? So the reason I looked at this problem, because I wanted to talk about this problem, which is a spring mass problem. So this is x1, this is x2, and if you write the equation for this guy, those can be written in terms of incident matrices. Okay, so what were you saying? The C2 and C3 they get negative?
Like, the question says 1 to 3 is C.
I probably I read that question once. So you mean like this?
Yeah.
C2 and C3. So then this will become C3. This will become C2. How do you get the correct and same answer? Okay. So next is explain Euler's formula, which is the beginning of topology, by an example. So problem number 8. So number of nodes. So this is a very simple topological object. So there are 3 nodes, edges, and you can see loop, and you can see the Euler's formula is verified. So yeah, so Sonia, you're right. So please make sure that you have made this correction. I've just highlighted, because in the problem in the textbook, the weights are not like the weights I assume. Weights are just opposite. So if I want to correct this, I can correct it. C1 is on x2. This is C3. This is C2. Now you will get correct answer.
Just giving one example is fine, or we do more than one?
No, just one example is good. Okay. So you should be super comfortable with question 4. Yeah, question 4. Yes, question 4. So for question 4, there are multiple ways of solving the problem. And to be honest with you, I wouldn't recommend using one way or the other way. You can solve the problem with the technique that is given in the textbook, or solve the problem using the equation. The only thing that what you should do is finally you should verify your answer. You should verify, and for verification, what you should do is you should use these matrices AT and A inverse T. These two matrices, that you should use to find out the derivative of 80 square. And you can check if the answer makes sense or not. So the way I did that is I separated 80 multiplied by 80, and since the matrix manipulation is not commutative, so I took the derivatives and I came up with this formula. But if you want to use the basic definition of derivative, which is a plus delta a square, subtract a square and then divide that by t, then you should be able to get the similar answer. The only issue is, please note that the matrix multiplication, you cannot assume it to be commutative. What it means is a times delta a is not equal to delta a times a. So don't, just keep that in mind and you should be okay. Any other questions? So what I'm trying to say here is this. So this is the hint for problem 4. So if you want to do a plus delta a square, please note matrix square operation is really not defined. What you have is a plus delta a multiplied by a plus delta a. So when you expand this, this is going to be a times a plus a times delta a plus delta a multiplied by a plus delta a multiplied by delta a, right? Then from here you want to subtract. So what is the definition of derivative? Definition of derivative is function h plus delta h minus function h divided by delta h, where limit delta h tends to 0. So if I want to write this, I would write a times a plus a delta a plus delta a plus delta a minus a multiplied by a divided by delta t, limit delta t going to 0. Now here this guy can get cancelled with this guy. Do you agree with me? Now the next part is you have delta a multiplied by delta a, that is very small quantity. So this actually is close to 0. So that goes away. And now you have a delta a divided by delta t plus delta a delta t a, and then your limit delta t is going to 0. So you have a dot plus a dot a. So that's what I try to do, but here but if you used some other formula, to be honest with you, I did not understand how you did it, but just what I would recommend is no matter what formula you use to verify, if you use an inverse relationships, use AT is equal to 1 t square 0 1 and A inverse t is 1 minus t square 0 1. Okay. All right. Any questions from my online students? Okay, so I just quickly want to give you a brief overview of material that we have discussed so far. We looked at the important tools in linear algebra. We looked at the application of linear algebra. We looked at randomized linear algebra, compressed sensing and its application. Also, we looked at the Fourier transformation, Fourier matrices, and I gave you a brief introduction on neural networks. Now, what we are going to do is in the next class, we will try to cover the material that I kind of skipped or went a little bit quickly. And then we are going to look at the actual deep learning. And we will, depending upon the time that we have, we'll look at the recurrent neural networks, reinforcement learning, transfer learning, and these new concepts and how they are associated with linear algebra. Let me caution you that the theory part behind these techniques is going to be super boring. But the practical part or running the MATLAB scripts is going to be interesting. But personally, please pay attention to the theory part, because if you want to build on to that knowledge and apply it to some different cases, then having a good understanding of theory is very important. That being said, I just want to make sure everyone is doing okay with the MATLAB courses. Are you on track? Okay. Your assignments are graded. Any question with the assignments? Grades? Any other questions? Yeah.
Here is assignment number, like right now we are solving that. In 6 number, I am not able to verify the equation given.
Which equation? You are not, it doesn't give you the same answer. Okay, let me work out that problem. And which problem 6?
Page number 178, problem number 2.
Page number 176. Is it part of the homework file? Okay, I am. What problem number is that? Can you tell me real quick? 6. 1, 2, 3, 4, 5, 6. Okay, problem number 6. Find the eigenvalues lambda 1t and lambda 2t of A. Can you tell me what is the value of A you used? Let's problem number 6, right? Oops, problem number 6. Tell me what is the value of A? Go ahead. 2 plus t, then 2, 1 plus t,
Just 1 plus 2.
right? 2 plus t, 1 plus t, 1 plus t, and 0. So just t, right?
Yeah.
Is this something? Okay. So did you do SYMS T and then did EIG A? and then substituted t is equal to 0, and you got some eigenvalues and eigenvectors, and your eigenvectors are different than the eigenvectors Jesse said. Is that what you're saying? Or what do you mean not able to verify? Oh, you mean d lambda by dt is equal to, is that what you're saying? Okay, all right. So d lambda by dt is equal to y transpose dA by dt x. Okay, I tried to do this problem by hand. So I will tell you the answers that I got. So d lambda by d lambda 1 by dt. Now I have y transpose. So my answer was 0, 1, 2, 0, 2, 0, 1/2, 1. So I was able to get the answer, but I would be happy to look at your answer and see if it's not matching, or if it's but let me ask you this. You did this for t is equal to 0, right? This equation, did you apply at t is equal to 0? Huh?
I kept both of them in the equation. I didn't replace the equation.
So replace t is equal to 0 and see what happens. I think then you will get the correct answer. Okay, online students, any questions? Any other questions? Oh, yeah. So those are the eigenvectors. So basically, yeah. So basically, for lambda 1 at time t is equal to 0, you're gonna get one eigenvector, and then I actually didn't discuss this in detail about the interlacing of eigenvalues. So those are basically the transformed eigenvectors. Let me just say that transform eigenvectors. So yeah, we really didn't discuss the interlacing of eigenvalues because, all right, since you asked, don't blame me. Okay, so if you have a matrix that is changing with time, okay, so what does that mean? So it means that you have a matrix, and I'm going to take the example that I kind of discussed in last class. You have x dot, which is the state variable, 0, 1, then you have k 0, x dot. This is the matrix that talks about the time evolution of the differential equation mx double dot plus kx is equal to 0, where m is equal to 1. So x double dot plus kx is equal to 0. This is the equation. Now, the stability of this system is governed by the eigenvalues of that matrix. But imagine a case wherein your stiffness matrix is changing with respect to time, and that can happen a lot in a lot of cases. So when your stiffness matrix is changing with time, your eigenvalues of the matrix will also change with time. But the problem there is those time varying eigenvalues do not dictate the stability of the system. those time varying eigenvalues do not dictate the stability of the system. So for that, you need different mathematical machinery to solve the problem. And that totally depends upon whether KT is periodic, KT is non-periodic, KT is quasi-periodic, and so on. So depending upon that, there is Floquet theory, Lyapunov-Floquet theory, Lyapunov-Perron theory, and all that kind of stuff. But the crux there is this problem, if it is said x dot is equal to ax, associated with that, there is an adjoint problem. And that adjoint problem is given as something like y dot is equal to minus A transpose y. So x are the eigenvectors of this guy and y are the eigenvectors of the adjoint problem. And you need both these problems to understand the solution completely. So, well, my PhD was in time periodic systems, so I can go on and on, and even my research is in time periodic and quasi-periodic systems, so I can go on and on. But that field is very vast. So I'm just going to stop here, but be happy to answer any more questions if there are any questions. I'm going to stop here today and be happy to answer questions.